ويريكم آياته فأي آيات الله تنكرون.
From the galactic bodies to the tiny creatures, from the strongest to the weakest, everything in the nature follows some specified functions with precise measurements. It's because they're destined to do so. Let's for a moment think about the work of engineers or architects. They use functions and measurements to provide some properly functioning products with aesthetic appearance. In order to give you an example, let's think of a very simple function to draw a pattern in a circle, like 2x. So we start with a circle that has 10 equidistant points. Then we assign numbers to every single point. And we want to join every point with the help of given function by just replacing the x values with the number of each point. We start with the 0. 2 times 0 equals 0, so it's the same thing. Now 2 times 1 equals 2, so we connect the 1 to the 2. Then 2 times 2 equals 4, and we connect that point to the point number 4. So we continue until we get this pattern. At the beginning we started with 10 points, but if we increase the number of points, then we'll get more and more precise result with a cardioid shape. And if we change the function itself, we'll get many different patterns. But let me ask you something. Have you seen something in the nature that follows the same function? Well, the answer is yes. If you observe the reflection of light in a circle or object, like a coffee cup, then you can see the same pattern. That means the photons of light are following the same function by hitting one edge of the cap and reflecting to the other edge at a calculated angle. Not only the reflection of light in a circular shape, rather everything else in the nature follows some specified rules and functions with extraordinary precision. To give you an example of the precision of those functions, let's consider the number pi. Pi is an irrational number which has infinite decimal places. It means if you have a computer at the size of universe, then the storage capacity of that computer would not be enough to store the exact value of pi unless you round it. So where did the number pi come from? It's actually the ratio of circumference of any circle to its diameter. It means a circle can always be calculated with the number pi if we have one of its variables. Now let's consider you have 2 sliding blocks and a wall, and we suppose that there is no energy loss and the surface has no friction. The first block starts by coming in at some velocity from the right, while the second one starts stationary. The simplest case is when both blocks have the same mass. The first block hits the second, transferring all of its momentum. Then the second one bounces off the wall, then transfers all of its momentum back to the first, which then sails off towards the infinity. 3 total clacks. What about if the first block has 100 times the mass of the second one? It's not entirely obvious how to predict the dynamics here, but to have a little bit understanding, let's just watch what happens. That second one will be bouncing back and forth between the wall and the first block with 100 times its mass, slowly and discreetly redirecting the first block's momentum to point in the opposite direction. In total, there will be 31 collisions before each block is sliding off to the infinity, never to be touched again. Now what if the first block will be 10,000 times the mass of the second one? In that case, there would be quite a few more clacks, all happening very rapidly at one point, adding up all into 313 collisions. Well, actually, hang on. Wait for it. Wait. Okay, 314 clacks. If it was 1,000,000 times the mass of the second one, then again, with all our idealistic condition, almost all clacks happen in one big burst, this time resulting in 3,141 total collisions. Perhaps you have seen what's happening here. Yes, every time the number of collisions compute pi. It means the mechanism of collision in our assumed case was following a function that computes pi. Of course, such thing is maybe not possible in real physics because there are some other forces acting in the universe, but that's what happens when you calculate the number of collisions between two bodies in a condition where there is no other force like gravity acting on the bodies. Or just simulate this example in a physics simulation software, and you get the amazing result. It's because pi calculates the circles, and circles are everywhere in the nature. Because every time you have a curved thing and a straight thing, in order for them to interact, there's some pi going on. Nature doesn't like always going in a straight line because sometimes things interact. If you throw a ball in the air, it's not going to go in a straight line, it's going to go in a curve. And that means lots of things in the nature follows pi. A further example is the astonishing collection of numbers, the Fibonacci series. These numbers can be appreciated in many different ways. From the standpoint of calculation, they are as easy to understand as 1 plus 1, which is 2. Then 1 plus 2 is 3, and then 2 plus 3 is 5, 3 plus 5 is 8, and so on. This series of numbers was introduced by Leonardo of Pisa. In terms of application, Fibonacci numbers appear in nature surprisingly often. The number of petals in a flower is typically a Fibonacci number, or the number of spirals on a sunflower or pineapple tends to be Fibonacci number as well. In fact, there are many more applications of Fibonacci numbers. One of the most amazing characteristics of this series is the beautiful pattern that appears in them. For example, let's consider the squares of the Fibonacci numbers. Well, you may not expect something special by adding the squares of those numbers, but let's see what the outcome is. If you add 0 plus 1, you'll get 1. By adding 1 plus 1, you'll get 2, and then 1 plus 4, you'll get 5, 4 plus 9, 13, and so on. In this pattern, you are always escaping one number in the series. But what happens by cumulative adding of the squares of this series? Here is the result. 0 plus 1 plus 1 plus 4 is 6. Add 9 to that, you'll get 15. Add 25, you'll get 40. And then add 64, you'll get 104. The results are not Fibonacci numbers, but surprisingly the Fibonacci numbers are hidden inside these numbers. Do you see them? Have a closer look. Yes, 6 is 2 times 3, 15 is 3 times 5, 40 is 5 times 8, 104 is 8 times 13, and so on. But the most beautiful characteristics of this series is that it leads us to an important number called golden ratio. If you every time divide the greater number with its neighboring smaller number, then you will get the golden ratio. This ratio is also called divine proportion that can be found in numerous events in the nature. These were only a few examples of the perfect order that's being followed by the nature. The reason we have shown all of these to you was to once again remind you that everything in the nature is calculated with precise measurements, and that everything in the existence follows the functions that are set for them. Any rational mind can easily understand that none of these laws and regulations comes out of coincidence. Rather, such a complex universe with all its laws and functions needs a wise designer who created everything with perfect precision and set these rules to govern the entire existence.
الذي له ملك السماوات والأرض ولم يتخذ ولدا ولم يكن له شريك في الملك وخلق كل شيء فقدره تقديرا